Okay. Good afternoon, dear colleagues. My name is Alhanov A.A. I'm a computer science teacher at Nazarbayev Intellectual School. I teach 12th grade students, and today I'd like to conduct an online lesson on the topic which is from Unit 3A, Web Technologies and Operating Systems. Today we are going to cover some learning objectives like contrast the Internet, the World Wide Web, and intranet. Give examples of applications which use the client-server model. Describe security measures designed to protect computer systems ranging from the standalone PC to a network of computers, including user accounts, firewalls, general authentication techniques, including the use of passwords and digital signatures. And also we're going to cover showing awareness of other protocols, HTTP, FTP, POP3, SMTP, and their purposes. Describe the different types of application software and the criteria for selecting appropriate software for particular purposes. Okay, so let's get started. Before we start, let's think of what is the difference between the Internet and the World Wide Web. So how do you think? I would like to give you 1 minute to think about it. Okay, now let's have a look. What is Internet? So, Internet, as you all probably know, is a massive network of networks. It's a networking infrastructure. It connects millions of computers together globally, forming a network in which any computer can communicate with any other computers as long as they are both connected to the Internet. Information that travels over the Internet does so via a variety of languages known as protocols. And further, let's have a look. What is the WWW or World Wide Web? So, World Wide Web is simply web is a way of accessing information over the medium of the Internet. It is an information sharing model that is built on top of the Internet. The web uses the HTTP protocol, only one of the languages spoken over the Internet, to transmit the data. And as you probably remember, who invented the World Wide Web? Of course, it was the Tim Berners-Lee. Next, let's have a look. What is the intranet? So, an intranet is a computer network as well, which uses Internet Protocol technology to share information, operational systems, or computing services within an organization. Next thing we're going to have a look is the client-server model. So what is a client-server model? In history of computers, there were a lot of mainframes and super computers which were performed a lot of difficult tasks, a lot of requests, and nowadays the client-server model is one of the most popular, and it is used in a wide range. And as you know, all our devices, our gadgets, they all are clients. We all are clients, and we send the request to the server via the Internet, and then server operates. Then server sends the answer, respond to us back. So one of the examples of client-server model. As an example of modern client-server model, let's consider a video sharing website. The website, let's call it YouTube, has a server that stores all the videos that are uploaded to the site. The website is used by millions of clients a day, and each of them connects to the server to watch videos. When a client connects to YouTube, the server and asks for a particular video. The server loads the video into RAM from a large array of hard disks, and YouTube sends the video to the client. The client, on receiving the video, presses play and watches the video. So, as you understand, nowadays the client-server model we come across with this model every day when we send a request to any website, when we want to watch some videos, or if we want to download any documents, any files from a particular website. Okay, so let's carry on. So what is actually server? Server is a computer program running to serve the requests of other programs, the clients. Server software could include printing, file sharing, game hosting, websites, or other web services. And also one of the examples can be, for example, let's assume that we are working in some building and we have network inside this building, and we could have some server which is printing server. So this printing server helps us to print our documents from any computer in that particular building. So it provides us very useful and efficient usage of server client model. So what are who are the clients? Clients are software programs and processes that connect to servers, sending requests and receiving responses. Client examples could include web browser page requests, chat systems on mobile phones, and online games. As you can see in this picture, client sends a query to a server, then server operates and makes a response to the client. Also, you can see that server could use database as you can see in this example. So client sends the query to server, then server looks for that particular information which was sent by the client in the database, then database sends back to the server, then server responds to our query. Okay, good. So next, now I would like you to think and create a list of as many different sorts of software as you can record them on the board. Think of software which you used maybe in your daily life. You are given a minute to think about that. Okay, so let's carry on. So here I'd like you definitions of different software types, and you have to categorize the different sorts of software. So let's read the definitions. Small, powerful programs with a limited capability They are usually operated by the user to maintain smooth running of the computer system. Various examples include file management, diagnosing problems, and finding out information about the computer, etc. So notable examples of these programs include copy, paste, delete, file searching, disk defragmenter, disk cleanup, compiled collection of subroutines, and compiler, assembler, and interpreter, to which software type we can refer these things, this software. So think about that a little bit, and we will carry on. Okay. So what were the answers actually? So the first one, small powerful programs with a limited capability, they are obviously, it's a utility programs. Of course, this could be antivirus programs, disk defragmenters, disk cleanup. All these things are utility programs. Another one is a compiled collection of subroutines. Of course, it's library programs, and probably you didn't come across with any difficulties when you had to find out what type of software is that. And this last one is a compiler, assembler, interpreter. So of course the last one is a translator software, which helps us to translate from one language to another language. For example, from machine language to high-level programming language, let's say. Okay, next. So some more software definitions here. So the first one, software designed to operate the computer hardware and to provide a platform for running application software. How do you think? What is this one? And second, a collection of programs that make the computer hardware conveniently available to the user and also hide the complexities of the computer's operation. These software, such as Windows 7 or Linux, interprets commands issued by application software. Word processor, for example, or spreadsheets. And the last one, software designed to help the user to perform specific tasks. So I'll give you 1 minute to think about these software types. Try to categorize them as much as possible as you can. Okay, let's have a look at the answers. So the first one is a system software designed to operate the computer hardware and to provide a platform for running application. Of course, it's a system software. Second one, it's here you have some hints such as Windows 7 or Linux. It's obvious that this one is operating system. And the last one, the specific tasks. Of course, specific tasks can be performed only by application software. And as you probably remember, application software can be divided into several types, like bespoke application software, off-the-shelf application software, or generic, and other types of application software. So here another task for you, filling the empty boxes with appropriate software types. Here we have software, and we know that there are main two types of software, so you have to find out what types are they. And also these types can be divided into several types. So think about these types, and I'll give you 1 minute. Okay, good. So let's carry on. Here you can check your answers. Of course, software, the main two types are application software and system software. Application software can be divided into 3 types: general purpose, special purpose, and bespoke. System software can be divided into library programs, translators, utility programs, and operating systems. Meanwhile, translators can be divided into other 3 types: assembler, compiler, and interpreter. Okay, well done, guys. Let's carry on. Next thing we're going to cover today is the hashing. What is the hashing? Now I'll explain you. So hashing actually involves applying a hashing algorithm to a data item known as the hashing key to create a hash value. Hashing is used so that searching a database can be done more efficiently, data can be stored more securely, and data transmissions can be checked for tampering. Okay, if it's a little bit confusing for you, don't worry. Just in a minute I'll explain you in more detail. So there are also hashing tables. So to build, why do we need hashing tables? Actually, we need hashing tables if we want to find someone in a database, some data, some information very fast. If we want to find it rapidly, hashing will be very convenient and helpful thing. So to build a set of hashing values, we use a hashing algorithm to create a hashing table. Take a look at diagram below. By applying a hashing algorithm, each data item or hashing key has a hashing value. So as you can see here, this hashing, we have hash key, and also we have hash function. So hash key, this is hash function, and we have hash value. How can we figure out this hashing value, and how can we use the hash function? So this is a minimal perfect hash function for the 4 names shown. Now if we decided to search for, let's say, Sam Doe, we just apply hashing function, then we will find the hash value. We could search the hashing table for hashing value 3, and if we found it, we would know that Sam Doe does exist. Okay, next. But everything is fine. But what about searching for an item that doesn't exist? Take a look at this example. So let's say we're looking for John Thompson. We will apply some hashing function, then we will have hashing value 9. We can now search the hashing table and can see that there is no entry for hash value 9. Therefore, that data doesn't exist, and we didn't have to search through all the data to prove this, since we know that there is no hashing value 9. Okay? So, what is the hashing algorithm or hashing function, hash function? A hash is supposed to be repeatable. That means each time we apply it to the same data, we should get the same hash value out. This requires that we create a hashing algorithm or function. Take a look at this. For example, this example of hash function, hash key mod 6. If we apply this to the following list of hash keys, we will have the following hash values. If you don't remember what mod means, I'll remind you. Mod, it's a modulus division which shows us a reminder of the value. In this particular situation, it's a reminder of hash key. So we divide this hash key to 6, and if we have some reminders, then the reminders will be written in hash value. So as you can see, reminder of the after performance of this hashing algorithm of the first hash key is a 3. Reminder of performance the second hash key is 4. Third 1, 5 and 2. Okay, let's go next. So once we have calculated the hash values, we can start to build the hashing table. Notice, because we are using mod 6, we have 6 different possible hashing values. Okay, so this is our hashing table, hash table. In hash table we have hash values and hash keys respectively, which are referred to a certain particular hash value. Now if you were asked whether the hashing key 23,044 and 448 was a member of the data you have been given, you will do the following. Use the hashing key, apply the hashing algorithm and calculate the hashing value. Check for the hashing value in the hashing table. If it exists, you have found the data. If it doesn't, the data isn't there. So as you can see, there is no hashing key for hash value 0. That means that it's not there. It means that table doesn't contain such kind of value. So let's summarize now. As you can see here, this one is a hashing table, and this is our hash key, hash algorithm and hashing value. This is the whole our hashing operation. So we take hash key and divide it to 6 and calculate its reminder. As you can see, the reminder here is 3. Here 4, here 1, here 5 and here 2. Now let's check our hash table. In hash table you can see that hash value 0 has no hash key, and that's true because as you can see here we have no hash value 0. We have 2, 5, 1, 4, 3 but no 0. For example, let's have a look at for the next hash key. For example, hash key 34,237 hash refers to hashing value 1. Let's check. Let's find hashing value 1. Here is it. And hash key 34,237. Yeah, it exists. So that means we can put it in our hash table. And this way hashing helps us to find any data information in the database or tables very fast, very quickly, because we don't have to look through the whole database, since we know that this hash key doesn't exist because there is no hash key with such a hash value. This saves our time. Such kind of approach saves our time. So, as you can see, 23,448 mod 6 equals remainder will be 0, equals to 0. So nothing attached to 0, as you can see here, nothing attached to 0 in the hashing table. Therefore, that means that 23,448 isn't stored. Okay, let's go further. So now let's have a look how to use regular expressions, implement a scripting language password complexity checker. Now I'd like to show you how can we I'd like to show you example of how to check the password. Is it strong enough? Is it strong or not? So here, as you can see, when we, for example, now I'm typing only digits. If we have just the digits characters only less than 6, then the password, that means that it's not safe password. It's not good, well protected. If we add more, you can see that password is very good, is a strong one. It's a strong password. So how can we increase the password safety? How can we make our passwords safe? We can add capital letters, small letters, characters, digits, and other things. And you know all these things. This is making strong passwords is one of the way how to make your data, keep your data safe. So previously I told you that hashing helps us in different ways. It helps us to search data very fast in the database. Also, hashing helps us to make our passwords stronger. And now I would like to show you one video. This video is taken from YouTube, and this guy who will explain you in more detail how we can implement this hashing in PHP programming language. And he will use this some special hashing functions like MD5, SHA1, and other functions. Now let's watch this video.
Okay, so in this series we're going to specifically talk about password hashing and look at some secure examples of hashing passwords so they're suitable to store in a database. So if you're not sure what hashing is, or you're hashing passwords at the moment, perhaps using MD5, then this series is for you. So basically, applying a secure hashing algorithm to a password storing it into a database means that if you do it properly, it makes it extremely unlikely that it will be brute forced if your database is exposed. So if an attacker gains access to your database, say your users table, and has a list of passwords, if they're hashed properly, then you're less likely for them to be brute forced, and you're adding another layer of security there. So we mentioned MD5, and if you've looked at MD5 before, then it's a good idea to note that it's not a good solution to use this to store passwords in a database. So the function looks like this in PHP, and if we go ahead and just choose a password, I don't know, we'll choose something maybe more sensible. So we're going to choose a password like this and go ahead and refresh our browser. And you can see that we get this hashed string here. Now you'll note that every time I refresh, the same hash is generated. So if, for example, 2 users in your database had the password tabby12345, their hashes that are stored in the database would both be this value. Now that's a little bit concerning, because if an attacker gains access to a database and has access to one account, if a user's using the same password, they then have access to the other account. And basically, using MD5, nowadays it's so easy to brute force this. And brute forcing is basically looking up in a preset list of values in a table of values that could be this value. And there are all sorts of complicated ways that you can go ahead and brute force, and we'll be looking at an example of this in a moment. So basically, if you look at an example like this, you see we've got a hash generated, and later on we're going to go ahead and look at actually brute forcing this. So let's go ahead and look at an example of actually generating a hash and then going ahead and comparing this. This is if you're not familiar with comparisons of hashes at all. And it's a basic example, and then we'll look at actually brute forcing this value using an online tool. So we know that I've just used the MD5 hash to hash this tabby12345 password, and I have this hash from it. So I'm going to go ahead and I'm going to copy this, and in my text editor I'm going to go ahead and I'm going to create a variable called stored password. Now you have to use your imagination and imagine that this value is stored within a database somewhere, and I'm a user coming onto the site attempting to sign in. Now, once a user enters their username and their password, they would supply their password as tabby12345 if that was their password. So what you would then do is you'd create probably an if statement to say, does this password equal this password? Now, because this is a hash, we can't reverse it. There's no way to actually reverse this value and then get the plain text string from it. The algorithm won't allow for that, because it's a hash, it's a one-way hash. So what we need to do is we need to say, instead of something like does tabby12345 equal stored password, we need to say, well, let's rehash this plain text value that's been provided to us. And because we already know that the MD5 hash will always be the same, we go ahead and get the same value here and the same value here. So we can go ahead and echo something like you're in. Or if the password isn't correct, we could go ahead and echo something like sorry, try again. So let's go ahead and take a look at this and see what it looks like in the browser. So when I refresh, it says you're in, but if maybe I slip up and provide one extra letter on there, you'll see that it doesn't work. So that's basically how a login process would work, and how hash you compare a hash to a stored value. So we know this works, but let's take this hash and go ahead and see if we can brute force this value out of it. Now, if you have signed up to a website, you might think that a password like tabby12345 is secure enough, but you'll be surprised to see that if we go over to a website like CrackStation, we can go ahead and actually reverse this. So I've pasted in the hash in here, and notice this says non-salted. So we'll explain salts in just a moment. So let's go ahead and just type in this captcha, and I'll go ahead and crack hashes. So what's going to happen now? It's going to perform a lookup and brute force this value, and you can see below here, surprisingly, it's actually given us the value. So it's gone ahead and looked this up, and it's actually brute forced it or cracked it successfully. So now we start to worry, and we think to ourselves, well, in this case, if this can be cracked, well, what do we need to do? Well, basically, PHP has within its functionality a function called crypt. So the function looks like this. And this basically lets you securely hash a string, provide a salt, and all a salt is it's something that's added to a string to change the value of its hashed output. So just as an example, and this is just as an example, I'm going to go ahead and I'm going to use MD5, and perhaps provide the value tabby12345 again. Now, if I go ahead and apply a salt, for a different salt for every single user, and in this case, all I'm going to provide is PHP's time value. Now, this is not recommended to do at all. This is just an example. Because time changes all the time, go and have an append this like this. So I'm going to go ahead and append this value that's returned from time onto the end of this. So what then happens is when I refresh, the hash changes every single time it's generated. So this is basically what a hash does. This is just a silly example, a non-secure example, but that's what a hash does. So hashing the password like tabby12345 again and again and again with MD5 will return the same hash, so it's insecure. But the crypt function I mentioned a second ago lets you securely hash a password, add a salt, get the returned hash. You can go ahead and store that. However, we're not going to look at the crypt function. We're going to make life even easier for ourselves with it, while we still enforce as much security as possible. So we're not going to talk about crypt. We're going to talk about the password hashing API that PHP provides from version 5.5 onwards. So go ahead and check your PHP version. If you're not too sure, just type PHP info into a PHP file. That will give you all the information about your PHP installation. If you go ahead and check that out, I'm running PHP 5.5.9, so I have the ability to use the password hashing API. If you are unfortunately running something under 5.5, you're not going to have this ability. So go ahead, upgrade to version 5.5 if you haven't already, and in the rest of the series we're going to look at using this password hashing API to securely hash passwords that are perfectly acceptable and safe to store in a database.
Okay, so dear colleagues, as you have seen, this hashing could be very helpful in password safety as well. You can store your passwords in a database more safely. How it can be useful? For example, let's assume that your database was hacked, was stolen. So, for example, that person who stole your database, he cannot use your passwords because if all of your passwords are hashed. This provides a lot of good things, useful things. Okay, let's carry on. So, I would like to give you a task. So, I want you to research in pairs different methods of keeping people safe on their computer and when using networks. Each pair present their findings to the rest of the group. So, as you can see, it's a pair work. Okay, you are given 2 minutes for this. Okay, good. Let's carry on. So one of the methods could be firewall. Of course, you know firewall from the previous units, from the previous topics. Firewall provides us some protection from the bad, for example, let's say attacks from hacking when we are using internet. And other things can be authentication techniques. So, as you know, authentication means you provide your username and password, which then you probably can get some access code in order to get an access to a certain system, to a particular system. Okay, next. The last one is a digital signature. So digital signature is used a lot nowadays as well in order to protect your data, to keep your data safe. Other things are user accounts. If every user has his own account, that makes his using of computer, any electronic device more safely. He can store his data and do whatever he wants with those data without any without any scare of losing all this data. Next thing I would like to show you are the examples where the protocols are used. So examples of protocols might include sending emails, playing games, sending files, having video, conversations, loading secure web pages, connecting to servers remotely. So probably you heard before what is a protocol and you're aware of it, but let's refresh your mind. So with networks and the internet, we need to allow computers to talk to each other. To make sure that a computer talks to another in a way that the other understands, there are sets of rules governing modes of communication. These rules are called protocols. There are many different protocols out there, each defining rules for specific communication types. So, what is a socket? Socket, it's a combination of port and an IP address. In this picture you can see that port is 80 and IP address is this one. So in general it's all socket. And I would like to show you some well-known ports. Here you can see, for example, port number 21 is used for FTP protocol, so file transfer protocol. We use this protocol, we need this protocol in order to send files from one device to another device via the network. And there are also one of the popular protocol is a hypertext transfer protocol or HTTP protocol, which uses 8080 port numbers. Okay, let's go next. What are the protocols and port numbers actually? So protocol is a set of rules governing the way that devices communicate with each other. And port number, an application or process specific communication endpoint attached to an IP address. So now I want you to match the correct protocol and port number for each. So you are given a minute to complete this task. Okay, good. Let's check your answers. So, as you can see, here the port numbers and respect and the file and the protocol names refer to each other. So, and the last task for you, it's your homework. I want you to make research whether the security is better handled by the server or by the client. So you have to make a research at home and write a small report on this. So here's some reflection. What have you learned? What would you like to know? And what would you like most of all from all these things which I taught? And here are some resources which I used in order to conduct this lesson. And this presentation you can download from this website, moodle.nisedu.kz. index.php. Thank you for participating.